One of the questions I had when I first started creating in audio was whether the .NET framework was suitable at all for creating audio applications. Would performance be good enough, or would it be better to write applications using C or C++? Well, the good news is that even though .NET is a just-in-time compiled language, performance is actually pretty good. You can create many audio applications in .NET with no troubles whatsoever, even though perhaps you would get slightly better performance if you used C or C++. But one of the big issues you do need to be aware of is that .NET uses a garbage collector. And garbage collection can impact audio applications in two ways. First of all, your process can be interrupted. The garbage collector can kick in at any time and stop your code from running while it's doing the garbage collection. And if you're working with low latency audio, this can cause a glitch, where there's a small break in the sound coming out of the sound card. One of the simplest ways of working around this is to not try and work at extremely low latencies. So for example, giving 100 milliseconds of audio to the sound card each time is better than only giving 10 milliseconds of audio to the sound card each time. Because then if a garbage collection happens within that 100 milliseconds, you've probably still got time to fill the next buffer. It's also probably a good idea to try and write your code in such a way that doesn't create extra work for the garbage collector. I've tried to do that in mAudio, creating objects up front and reusing them, rather than constantly creating lots of objects that get thrown away. It reduces the amount of work that the garbage collector needs to do. But if you're writing a GUI application, there still will be work for the garbage collector, so it will happen from time to time. The second big implication of the garbage collector is that garbage collector can move structures in memory. Now this is fine in normal .NET applications, but if you've given a pointer to a structure to an unmanaged API, such as a Windows Audio API, then if that structure gets moved in memory, it can cause all kinds of horrible access violations. So you need to pin any structures that would be passed to unmanaged APIs, so that the garbage collector isn't allowed to move them in memory. And that's something mAudio is going to try and do for you, so you don't have to worry about this, as it can be a very frustrating and error-prone process trying to get all your pinning correct when you're doing interop to audio APIs. Another issue is the language support that you need to work with audio. In C# you can actually use pointers, but you're only allowed to use them with the unsafe keyword. And I didn't want to make mAudio require the unsafe keyword to be used. So mAudio actually often passes audio round as a byte array. But the .NET framework won't let you directly cast from a byte array to a float array for 32-bit floating point audio, or a short array for 16-bit integer samples. So this can make the audio very inconvenient to work with. mAudio's got a couple of tricks to help us work around this, and we'll be looking at those later in this course.